Hello, my name is Rafe Daniel. Well, this presentation will cover case study 6.1 about quality control for variables about the Whisk Wheel Company. I'm going to walk you through what these processes look like over 3 days and show you charts I created and explain what they mean. So the background and the problem of this assignment is the Whiskey Wheel Company makes chrome moly bicycle hubs, and their biggest customer has been complaining about quality. So we were asked to look into the process. The hub length has to be 3.75 inches, plus or minus, for tolerance, 0.005. My job is to check whether the cutting processes meet those requirements and to show you the charts and graphs of how they do. For the sampling sizes and information, the operator measures 6 parts for every 30 minutes, which gives us a total of 24 subgroups a day. We're looking for day 1, day 2, and day 3. Each day has exactly 144 measurements, and I use those numbers to make histograms, X-bar charts, and R charts, and then take that information to explain what they mean and how they correlate with each other. For my part 1 overview, I had to make a histogram for day 1, calculate the estimated sigma values, and figure out the percent of parts if they were above or below the spec limits. So I'm basically summarizing day 1 results, determine percentage above or below specs, and completing my day 1 histogram. This is my day 1 histogram. Pay attention to many things and also get a good look at it because I will be talking about it in the next slide. Pay attention to stuff like shape, what the spread is, was it running smoothly, and does anything jump out at you or jump around through the chart? So, within that chart, you can tell many things, such as the shape does not look normal. It is kind of uneven, very, very spread out. So it tells me the process was not running smoothly on day 1.
Is that it?
So the day 1 sigma and specs. So to look at capability, I used the average range of day 1 and divided it by the correct D value for a subgroup of 6. That will give us the estimated sigma values. Then I used to calculate the z-scores for the upper and lower spec limits. From that, I found the percentages of the parts that would fall above or below the specs. So basically, after looking over everything, day 1, it was not capable of consistently meeting the customer's requirements. So of course, this will bring in the big complaints and bring in all of the problems. Then we get to part 2. So for my part 2 overview, we added day 2 data and created an X-bar and R charts from both days together. We also made a histogram using both days. So we simply added day 2 data, added the X-bar and R-bar charts, combined histograms, and now we will evaluate the process. Here is the combined X chart. You need to pay attention to many things and take into consideration, is the process stable? Were the averages bouncing around a lot? Do they look like they're consistent? What could this mean? What could have actually made the process worse? This is the combined R chart. You need to pay attention to the exact same things. Once again, such as, is it stable? Were the ranges consistent? and really try to think of a problem that could occur from this and making the process worse. So, after looking at days 1 and days 2 charts, looking at the pattern, special causes, and out of control points, we come to the conclusion that when putting the two charts together, it is clear the process was not stable. You can see that because the averages were bouncing around a lot and the ranges were never consistent. After reading through the case study, it explains that the operator was adjusting the machine way too often, even when he did not need to, which this was actually causing to make the process a lot worse. This is my combined histogram for days 1 and 2. Pay attention to things like variation, the spread, and if the process was stable with these two days together. This histogram shows even more variation than day 1 alone. The spread is way wider and it doesn't look centered or consistent. This confirms the process was not stable on these 2 days. So once again, why is it unstable? That is the big question. We ask at this point. So on day 1 and 2, the operator was changing and regulating it way too much, and this killed the process. Then we arrive to part 3. My part 3 overview is doing the day 3 histogram, X-bar, and R charts by itself. We will evaluate improvement and come to a conclusion. These only include day 3 data. Also, within day 3, the operator was told to stop adjusting the machine unless the chart showed a real significant signal. All right. This is my day 3 X-bar chart. Now, we can notice a lot of things about this. What do you think about it? Is it stable? Is it tighter? What do the numbers tell you? Does the operator quit making unnecessary adjustments help the process? This is my day 3 R chart. Once again, pay attention to the numbers. Look at how it's grouped. Look how the chart flows. This is my day 3 histogram. Once again, pay attention to the numbers. Is it more stable? Tighter? Does it look like a normal chart? Or does this look like a normal histogram? Once again, what do you notice about the operator quit making unnecessary adjustments? So now we get to my day 3 overview. So there are way fewer extreme values. We see normal shape. So basically, we see all ranges are much more stable. The ranges are tighter. The histogram looks way more normal. And this shows, without a shadow of a doubt, that once the operator quits making unnecessary adjustments, the process can settle down and become way more predictable again. So removing the simple factor of having this operator not making the crazy adjustments all the time, even when they're not necessary, will save production and make sure everything lines up and everything becomes way more predictable. Then we come over to my final conclusion. So overall, days 1 and days 2 weren't stable because the operator kept adjusting the machine without waiting for the control chart to signal a real problem. So, in theory, he became the real problem. On day 3, when he stopped adjusting every few minutes, The process improved a lot. The charts show that the process becomes way more consistent and way more capable of meeting the customer specs when the operator isn't constantly adjusting the machines. Stopping this solves the root problem. This comes to the end of my slideshow. To wrap up, we collected all our observation using the data to build histograms. The histograms helped us see the shapes of the processes, and we paid attention to things like center, spread, and if anything looked unusual or just way out there. Then I showed control charts that we built, and I went over the control limit, what the charts tell us about the process being stable or as if something's going wrong. We went over the point that goes above or below the limits. That's the signal we need to investigate. We talked about the defects. We talked about internal failures, external failures. But this is the overall. I would open to questions about any of our X bar or R bar charts, or if you have questions about any of the histograms that I have created, please do so in the comments. My name is Rafe Daniel, and thank you so much for watching my presentation.